question number 3, we're going to take a look at the table on page 833. It has data on the selling prices of used Land Rover Freelanders and their ages in years. So we want to find a linear regression model to predict the price of a used Land Rover Freelander based on its age, if appropriate, at the 0.05 level of significance. So I want to know, if I find a Land Rover Freelander that's 3.5 years old, what kind of price could I expect for that? I'm not buying a Land Rover anytime soon, but whatever. So to do this, the first thing we want to check is this even appropriate? Okay, it's a linear regression model, so we want to look at the scatter plot, and we want to see, is it even a linear situation? If it's not, we're not going to bother with this problem. So you're going to go to your calculator and edit. If you have to clear list L1 and L2, you can, but I went ahead and put my data in already. So here's L1 and L2. And then we're going to go to stat plot. Your plot may already be on from a previous problem, but if it's not, turn it on and make sure it's on scatter plot and your data is in L1 and L2. You do want to go to zoom stat again because you want it to zoom in on this data, not the one you did last time. And there it is. So scatter plot shows, I would say that's a linear relationship. Okay, because it does look like there's a negative relationship, which we would expect that. The older the car is, the less it would be worth. Now we want to know if this is statistically significant. Like, can we actually do this? So to do this, we are going to go to our linear regression t-test. And we're going to find out what is our R value and what is our P value to see if these are really significant. I'll make this a little smaller so we can see it. All right, so we're going to go back to our calculator, stat, test, and you're going to go down to linear regression t-test. Again, it's going to ask you where your data is. We always do not equal. And then if you don't have anything in here, we do want to store this equation because if it is statistically significant, we want our calculator to crunch all the numbers. So you're going to go to variables, y variables, function, y1, and that's telling it to store it in y1. And we'll go ahead and calculate that. Okay, so the things that we were looking for, we wanted to know what R was, so just scroll down until we find it. R is negative 0.86, I forgot the negative. So maybe not as strong as we've seen before, but that still indicates a strong negative. But what we really want to look at is the p-value, and I think I have to scroll back up to find that. Is this statistically significant? And you can see that P is 0.0013. And that is definitely less than our alpha, so this does state that it is statistically significant. Okay, because our p-value is less than alpha. So now that we know all that, we can safely write our equation. So notice in this form, it's in y equals ax plus b. So we just have to scroll till we find a. So there's our a. A is actually our y-intercept, just the way they have it written here. So 3, 4, 0, 5, 2. I'm going to go ahead and round that. And then b is a negative value, so minus 4, 2, 5, 8 x. And again, remember this is y hat. It's a predicted value. So what this is saying is if I found a Land Rover Freelander that was 0 years old, that's the y-intercept, I would expect it to be about $34,000. What our slope is telling us is that every year older it is, it's losing, $4,200 worth of value. Okay. All right, so we want to, in question 4, use the linear regression model if appropriate. Okay, so we want to know the selling price of a Land Rover Freelander that's 2.5 years old. If you remember back to the data on page 833, we had cars ages 1 to 4, so 2.5 is within this. So basically what we're doing is we are taking that equation and we're plugging in 2.5, okay? Which you can do it like this. That's going to give you a value. Remember, that's going to be a rounded value because I rounded both of these numbers significantly. If you don't want a rounded value, let me show you the 2 different ways you can do it on your calculator. Go to variables, y variables, function, and y1 is where we stored it. and then parentheses 2.5. We're saying I want you to take that equation in y1 and plug in 2.5. And they will tell you that you can expect this to cost $22,407 in some odd cents. Okay. You can also do this by doing the table. So remember, second table is here, and I have it set. If yours automatically populates, just ignore that. Go to table set and change the independent to ask, and then that enables us to plug in whatever we want. So if we want to plug in 2.5, there it is. Selling price of a Land Rover that's 10 years old, the calculator will do that for us, but remember our data was only for ages of cars 1 to 4, so 10 years old is way outside the data. So we would say for this one, we wouldn't say it way over there. It doesn't make any sense. This would be not appropriate since 10 is outside of the sample data. Make that smaller so you can read it. Okay, the sample data was from 1 year to 4 years. Okay, we want to know the selling price of a Honda Pilot that's 3 years old. Again, you can go over here to your calculator and plug in 3, and it's going to give you an answer, but remember this equation was for Land Rovers, not for Honda Pilots. So this one would also, why do we keep typing in weird spots? Not appropriate because our sample was Land Rovers, not Hondas. Okay, so it has to fit the data. Okay, we'll do one more example in the next